All right, let's take a closer look at the units of dynamic viscosity. I find this is sometimes a little bit confusing because depending on where you look up the values or the material properties for a given fluid for viscosity, you might find different units floating around. And in fact, sometimes the units will help you remember what type of viscosity it is. So as we'll see soon, there's another type of viscosity, which I think is a little bit confusing. Okay, let's take a close look at the units of the viscosity, dynamic viscosity. So according to Newton's law, there's a constant proportionality mu that relates the shear stress to the rate of change of velocity for spatially adjacent layers. So how quickly does velocity change as you move through space? So let's take a look at the units. So we can do this by sort of comparing the units on the left-hand side of the equation with the units on the right-hand side of the equation. It's an equality, meaning that one thing equals another thing, and therefore the total thing had better have the same units. So we can use this to figure out the units. The left-hand side is the easiest. So shear stress has units of pascals, or newtons per meter squared. So pascals is the left-hand side. The right-hand side, thus, must also have units pascals, but that's actually the total of two things multiplied by each other. So the derivative term contains velocity, which is meters per second, and the denominator of that derivative is per meter. So if I think about that as a fraction where I have meters per second at the top and meters at the bottom, the two meters cancel, so that's actually per second is the total. The total thing has units per second. And so by extension, that means that, since the right-hand side and the left-hand side have to have the same total units, viscosity must have the units Pascal times second. And that is actually the most common way for people to write the units of dynamic viscosity, Pascal seconds. But it's not the only way to write it, and in fact, our book does a really lousy job here, I think, and does not write the units that way. So if you go to other sources, including the Hibbeler textbook, you might find the units in newtons seconds per meter squared. So how do you get that? Well, pascals is newtons per meter squared. And so you just substitute newtons per meter squared instead of pascals. So you might find the units written as newton seconds per meter squared. Or if you're like a real nihilist, you might write it, you might actually break newtons down into kilograms meter per second squared, right? So that's like if you break down Newton's first law of motion or whatever into kilogram meter per second squared, then you can actually see that the total term actually also works out to be kilograms per meter seconds. So that is much less common to find in tables, but is sometimes found. The more common way you might see those type of weird units is if you're looking through really old documents. So back in the old days before SI units, so there was a unit system that was very common in physics called Cgs Units, which stands for centimeters, grams, and seconds. So it's kind of like SI units, but not quite. So in Cgs units, dynamic viscosity has the units grams per centimeter seconds, which even more confusingly is often called poise. So people might actually write that with the units p or even centipoise. So that would be e to the minus 2 times poise. Super confusing, I think. I think if you see anything that you find confusing, I would openly encourage you to use Google to just do like a unit conversion. But anyway, I'm just going to warn you ahead of time that there are all these units floating out there for dynamic viscosity, and you should try to recognize them. By the way, in case you're interested in why poise is a unit that people made up, one of the founders of fluid mechanics, or actually like I guess you would call it hydrodynamics, was a person named Poisson, and Frenchman. So poise is actually a truncation of that name. And, it's kind of like Newton's, right? So like Newton's is to commemorate Isaac Newton. Poise is to commemorate Poisson. In either case, like, it's a confusing unit, and you're better off using SI units. Okay, in this class, we will only use SI units. In fact, I will almost exclusively write properties in Pascal seconds, because that's the units that make sense to me. I would encourage you that if you encounter anything that's not in SI units in this class, just like immediately convert to SI units, because the English system really does get people killed.